There were 3/4 as many sweets in box A as in box B. Half of the sweets in box A and 3/8 of the sweets in box B were removed. There were then 152 sweets left in both boxes altogether. And we're asked how many sweets were there in each box at first. Okay, so we've got a box A and we've got a box B. And what are we told? That there were 3/4 as many sweets in box A as in box B. Now, what that's telling us is that box B is split into quarters, and that box A has the equivalent of 3 of those quarters. Okay. In a previous question, I started by we had a similar situation. I'm going to draw it sort of the other way around this time. So there were 3/4 as many sweets in box A as in box B. So we're comparing to box B. So it's box B that has the quarters. Okay. So 1, 2, 3, and 4. Okay, I've split box B. This is what box B has. And if this is what box B has, A has 3/4 of that. So the equivalent to 3/4 of what's in. And I'm going to split it up the same. Okay, so whilst if you look at A and you see that it has 3 equal parts, you might think, oh, well, A is divided into thirds. But you can also see that A is that what's a third for A is equal to a quarter of B, and that A has 3/4 of what B has. All right. Okay. So this is the situation that we have at the beginning, and we could label that because we know that this is a question where we have a beginning situation and an end situation, and we need to keep track. Okay, so this is at first, and so is this. Okay. So then what happens? Half of the sweets in box A and 3/8 of the sweets in box B were removed. Okay, let's deal with box A first. We've got that split into 3 parts. That's not, and 3 is not an even number that we can split in half. So what we're going to do is we can see that we could just easily divide. So this is going to be where half of box A is. And that means that I've split this part into half. So I'm going to do the same here. Okay. Right. So I can now, I'm going to shade in what is half. That's going to be half of the sweets in A are removed. And we're told that 3/8 of the sweets in box B were removed. And hopefully you've been doing some equivalent fractions, and you might notice, now currently B is split into quarters, but hopefully you'll notice that there's an easy relationship between quarters and eighths, and that if you split each of these into 2, like you've split these ones here and keeping all of the parts the same. Okay, so if we split that into each of these into 2, we end up with eighths, don't we? 1, 2, 3, 4, 5, 6, 7, 8. And we also know that all of these parts have the same value. This part is equivalent to this part. Okay, and what does it tell us? That 3/8 of box B's sweets were removed. So I'm going to shade in 3/8. Okay. It then says that there were then 152 sweets left in both boxes altogether. So I'm going to do this, and I'm going to say 152 left. All right. And this is where, now you could obviously redraw this. You could say, okay, this is the first situation. I could draw a second model to show the second situation. I don't think we need to do that. Okay, so we could, in fact, I could do another arrow to show that this is what's left. And again, this is what's left. Okay, maybe I'll do that in pink then. So 152 are left. Okay, so we've got a value of 152 sweets. This is what what's left represents. How many parts are left? Well, 1, 2, 3, 4, 5, 6, 7, 8 parts. If I divide 152 by 8, that's going to give me 19, which is how many sweets are represented by each of these parts. 19, this is 19, 19. Okay, 19. There we go. And these are all 19 as well. Okay, and in fact, because that's what we're interested in, how many sweets were there in each box at first. Now, I don't have to draw it all in, but I will. Okay, just so that you're really confident that you know that each of these parts represents 19 sweets. So what do I need to do? Well, I can see that box A has 1, 2, 3, 4, 5, 6 times 19. So this is A. 6 times 19, which gives us 114 sweets. Okay, and B, all right, that's 1, 2, 3, 4, 5, 6, 7, 8. 8 times 19, which gives us 152 sweets. And there we go.